Hello dear children of class 6 and welcome to another online class of geography. Dear children, today we will be continuing with the second lesson of our book, Elements of a Map. Now if you remember, in last video I told you that there are 5 important elements of a map. What are they? They are title, direction, that is north line, then you have scale, you have legend or key, and you have grid system. Now dear children, today we will be going through the third one. As you remember, in the previous video we covered title and direction. So today we'll be going on with the third element, scale. Now this is one word whose definition we covered in the very first video of the online class in chapter 1. So for your reference, I'll be writing the definition again. Scale refers to the ratio of the distance on a distance between two objects on a map to their actual distance on the ground. Okay, so dear children, scale refers to the ratio of the distance between two objects on a map to their actual distance on the ground. You see dear children, scale is a very important element of a map. Scale is what makes map smaller and convenient to carry. I'll give you an example. Suppose there are two places A and B who are 50 kilometers apart. If we imagine putting them on a map in their actual distance, you can understand that we will require a very large size of paper, which will not make it convenient to carry. So while drawing a map, what is done, in a particular ratio the actual distance is decreased, it is brought to a smaller measurable unit and it is shown on the map. This is what makes map easy to carry, because it decreases the size of the map, and that particular ratio is what is referred to as scale. All right, so once again I am telling you, scale refers to the ratio of the distance between two objects on a map to their actual distance on the ground. So it's simply a ratio. Ratio of what? Ratio of distance, what the two objects measure on the ground and what is their distance on the map. The ratio between that is known as scale. Now dear children, scale are of three types. Scale are of three types. First one is verbal statement. Verbal statement. Then you have linear scale, also known as graphical scale. And then in the last one you have representative fraction. In short, we call it RF. RF. Now children, scale is always mentioned in the lowermost corner of the map, and scale will always be in one of the three forms. Either it will be in a verbal statement, or it will be in the form of a linear scale, that is graphical scale, or it will be in a form of a representative fraction. But scale will be present. Without a proper scale, the map loses its very identity. It will not be a map anymore. It will be a sketch. It will be a sketch. So let's learn about three of these types of scales one by one. the first one we have is a verbal statement scale. Verbal statement scale is nothing, dear children, but a simple sentence which shows that what is the distance between two objects on a map and what is their actual distance on the ground. It is just a simple statement. For example, in the map, in the lowermost corner, if you see this one, 1 centimeters equals 50 kilometer. Only this much will be mentioned in the lower corner of the map. 1 centimeter equals 50 kilometer. If this is mentioned, then what we have to understand, 1 centimeter is the distance on map, 50 kilometer is the actual distance between the given places on the ground. So verbal statement scale is one of the most simpler forms of scale, very easy to understand. Then comes the second one, linear scale. Linear scale, also known as graphical scale. Graphical scale. Linear scale or graphical scale. Now you see, dear children, in linear scale or graphical scale, instead of a statement, it will be given in the form of a drawing. What kind of drawing? I'll give you an example. It will be in this type of scale, okay, this type of diagram, which will be divided into parts. Let's suppose this is divided into 5 parts. This is divided into 5 parts. So what this means? This simply means that, now suppose each of this part is 1 centimeter apart. 1 centimeter apart. So we have to understand that 1 centimeter is the distance between two objects on the map. And here suppose in the lower part it is mentioned 50, 100, 150 and 200. It means every 1 centimeter on the map represents 50 kilometers on ground. Also, the first part will again be subdivided. When it is subdivided, what it means? After subdivision, this particular part will show the distance of 25 kilometers. It means every 1 centimeter shows the distance of 50 kilometers and every half a centimeter on map shows 25 kilometers on ground. Remember this? In linear scale, instead of a statement, there will be a diagram. Now suppose this kind of diagram is there. So what this shows, every 1 centimeter on the map shows 50 kilometers on the ground. That means 50, 100, 150, 200 kilometers overall. And it can be more or less also, depending. It's just an example. And the first part will be subdivided into 2 or more categories, which shows that every subdivision equals a lesser distance on the ground. For example, in our case, we divided the first part into 2 equal parts. That is, 1 centimeter became half a centimeter, half a centimeter. It means if 1 centimeter on map shows 50 kilometers on ground, then every half a centimeter on map shows the distance of 25 kilometers. So I hope you understood the linear scale. Now let's move on to the third one, representative fraction. Representative fraction, also known as RF. Representative fraction, also known as RF. Now as you can see, the word fraction is involved. So obviously, as you have already learnt in math, fraction means it is shown in the form of numerator and denominator. For example, suppose in the lower corner of the map you find this kind of distance, 1 by 5000. So you know the top part is numerator, lower part is denominator. Now the numerator shows distance on a map, whereas the lower part shows distance on the ground. Okay, the top part, that is the numerator, shows the distance on the map, whereas the lower part, that is denominator, shows distance on the ground. Now, in order to show representative fraction, two rules are always followed. Number one, the numerator is always 1. Always 1. Okay, numerator is always 1. As we have seen in verbal statement only, scale distance on a map is always shown in the unit scale, 1 centimeter, 1 millimeter, like that. So here also, distance on a map, the distance which is shown is always 1, the unit distance. And second rule is that both numerator and denominator should be in the same unit. When I say same unit, what does it mean? It means in our example here, 1 centimeter on map shows the distance of 5000 centimeters on ground. Okay, 1 centimeter on map shows the distance of 5000 centimeters on the ground, because in representative fraction, numerator and denominator must always be in the same unit. Now suppose if it is, instead of 1 centimeter, if it is 1 meter, then what do we understand here? That 1 meter on map shows the distance of 5000 meters on ground. That means if we want to learn what is the actual distance, we need to convert the denominator into our required unit. Now please remember children, for study purposes, for convenient purposes, distances between two places on a map are always shown in centimeters, because all you students have a centimeter scale, which makes it easy for you to measure distances. So always the top one is centimeter. Now in representative fraction, if top one is in centimeter, that means the denominator will also be in centimeter. So like I told you earlier, if we want to know the actual distance on the ground, that is the kilometer distance, then we will have to convert this into our required unit. I'll show you how to do that. Suppose the representative fraction given is RF is 1 by 50,000. 1 by 50,000. Now as I told you, it is always taken in centimeters. So what we understand here, 1 centimeter on map equals 50,000 centimeters on ground, because they must be in the same unit. Now from centimeter we can convert it to meter. We know 100 centimeters equals 1 meter. So 1 centimeter equals 50,000 divided by 100, and this gets converted to meter. So what do we get here? 1 centimeter equals 500 meter. Now from meter, if you want to go kilometer, then you'll have to divide it by 1000. If you want to go to a bigger value, then according to the scale of measurement, we divide it by a particular number and we can convert it to kilometer or anything. Now please remember this one. This is just an example on how to convert the denominator of a representative fraction into any required scale. You can even go further and convert it to kilometers or decameter or hectometer, anything. Okay, now that we have learnt about scale, then question is how to measure distances on a map. That is measuring distances. Measuring distances on a map. Now dear children, if suppose there are two places A and B. Now if they are in a straight line, then measuring distance scale is not a problem at all. Measuring distances is not a problem at all. What we do, we simply put a scale, measure it and convert it as per the given scale, and we get the distance. Problem arises when instead of being in a straight line, they are in a curved line. Now as they are in a curved line, you cannot apply scale here. You cannot put a scale. How will you put it? Impossible. But there are two methods of measuring the distance, this kind of distance, curved distances. First one, number one, divider method. Divider method. Okay. Now, those of you who don't know, this is your divider. Till date, you have only used it for playing in class or for pinching others. Harmful object. Normally when we see you playing with it, we confiscate it. But here today you are going to learn how we use divider to measure the distance. Now suppose in a divider method, this diagram is there and we have to measure it using a divider. So in divider method, what we do, first we open the mouths of the divider 1 centimeter or 2 centimeters apart, not much. We put a scale like this, we put it on top, either 1 centimeter or 2 centimeter. Now let's suppose in our case, we will assume it is 1 centimeter, assumption. Now once we have assumed, start from beginning. Put here, first one is here. Now without moving it, that's your second one, third one, fourth one, like this. 1, 2, 3, 4. Suppose it comes 15 or 20. If it is 1 centimeter apart, we understand that it is 15 centimeters or 20 centimeters. Now that's how we use a divider. Remember, once again I am telling you, first we open the divider 1 centimeter or 2 centimeter apart. We can do that with the help of scale. Then we start from the beginning and we simply move the divider along the curved line. Along the curved line. It is difficult on the marker board, but on paper it is convenient because the divider won't budge. So the number of turns that the divider makes, to reach from point A to point B, with the number of turns we multiply the distance we have opened the divider on and we get our measurement. For example, if our opening is 1 centimeter, and number of turns from A to B has been 15. So we understand 15 into 1, 15 centimeter. Now just in case if it was 2 centimeters apart and still it has come 15 turns only, then 15 to the 30 centimeter. So you see, like this you can easily measure distance on a curved line. Now just in case if you don't have a divider with you, then there is another method known as the twine method. For twine method, you need a twine or a thread. Now I don't have a twine or thread at the moment, but what I can do is I can conveniently use my charger. Now consider this as a thread for the moment. Now how do we do with this? We simply put up a thread here, right? And we turn it, and turn it. So this much came out. Now what we do with this? We measure it on the scale. We get our distance in the centimeter. Now remember, in the divider method we use a divider, and in a twine method we use a thread. Okay, we use a thread. We simply put the one end of the thread at point A and we simply roll the thread along the curved line up to point B. Now how much of a thread is covered? We take that much and we straighten it and measure it on a scale. We get our distance in centimeters on a map. So you see, with the help of a divider or a twine, even curved lines can be easily measured on a map. Okay, so this children covers the scale part. In the next video we will be going through the legend or the key. For homework, kindly learn the definition of scale as well as try to learn about the three types of scale and how curved lines are measured using twine methods as well as divider method. Okay, thank you, stay safe.